Okay, so this right here cancels out and becomes 0, right? So all I have left is the v. Notice that the v is on the left side, or sorry, on the right side, and it's going to stay there. You can't move it to the other side. That's why you have that line there. Okay, now I have two fractions. They're both negative, so it's like I owe you and I owe you. So what do I do mathematically? I add them, okay? Now, if I'm adding fractions, I'm going to come over here to the side. What do I have to add a fraction? Same denominator. What would be the common denominator here? 6. So 3 to 6 is times 2. So times 2. So that becomes a -2. Remember how to add? This is a very simple fraction to add. I made sure it was simple. So what is -5/6 plus -2/6? -7/6. And if you want to leave it like that, I'm fine with that. -7/6. If digits tells you have to change it to a mixed number, you can change it to -1 and 1/6. But improper fractions are fine in the algebra world. We use them all the time. So it's fine to leave it like that. Okay? All right. So if all we've learned so far is addition and subtraction, what do you think we're going to learn next? Multiplication and division. So that's the second part of this. Okay? All right. So next slide. Again, you're going to see some that we can do mentally and some that we can't do mentally. Okay, so if you look at that first one, 4g equals 16. That's saying 4 times what is 16? The answer is 4, right? Okay, now look at number 2. 12 times blank is 26.
It's a decimal.
Oh, it's a fraction, right? So do you understand that there's going to be some that you're going to, or if you look at number 4, -2 times blank equals 1. Yeah, does that start to be like, I don't know what that is mentally? It is going to be a fraction. Very good. Okay, so let's look at the process again. All right, I'm still going to start with drawing my line. What is the opposite of multiplication? Division. But no more division signs. You may not use them for this. We're not using them. We're going to use fraction bars because we know that fraction bars mean the same thing as division because we're going to leave a lot of our answers in fraction form. We're not going to be using their decimal approximations because that's what decimals are. Okay, so 16 over 4 is a fraction. 16 over 4 would simplify to 4. And you already told me that. You knew that answer. Okay, but then we get to the next one, and we don't know what the answer is. So what process am I going to use? Division. And I'm going to divide both sides by 12. Okay, so divide by 12 with a fraction bar. Okay, so my answer is 26 over 12. That's my answer, but that's not in simplest form. So we're going to reduce it just like we did in the warm-up. What does that reduce to? What goes into both 26 and 12? 4 doesn't go into 26. 12 does not go into 26. 2. 2 goes into both. So 2 goes into 26 how many times? 13. 2 goes into 12. 6. So it's the fraction 13/6. And that might seem kind of weird, but that's the exact answer. And we can leave it like that. If you change it into a mixed number, that's fine. Yes? No, we're not writing them as decimals. No. Because the problem is if you get a decimal that doesn't terminate or doesn't repeat, then you have to round it. And then your answer is an estimate then. All right, number 3. What is the imaginary number that sits in front of all, oh, I couldn't even say it. Variables, very good, thank you. Okay, so we're going to stick in a 1 there. And now we're going to go back to the process, okay? So here was the same number over the same number. I divided the same number by the same number. Because, by the way, what is 12 over 12? 1. What is 4 over 4? 1. So doesn't that mean there's imaginary 1s sitting here? So that's what I'm doing. Okay, so what do you think I need to do on 3? Divide by what? Negative 1. Divide by -1. Because what is a negative over a negative? A positive. And we always want that variable to be by himself. Because remember I said he's like a bully. He picks on everyone. We need him by himself. Okay? The t must stay on this right-hand side because that's where he was. You cannot cross over this line. Okay? What would be 13 divided by -1? -13. And there's your answer. Okay? All right. let's look at the last one. This is one you guys said you couldn't solve mentally, but now that you know the process, what do you need to do? Divide both sides by what? Careful. -2. Because a negative over a negative makes a positive. That's why you want it to be the same, because that would be a positive 1p. And then divide this side. So p is going to equal, here's your answer right here. You don't even have to do anything. -1/2. Done. That's all you have to do. You just take the fraction and write it down, which means you don't even have to pick up a calculator. You don't even have to do anything else. You're just writing down your answer. Yes.
Well, now that you know the answer, it would actually be really easy to do the problem, because to get 2 to 1, you divide by half. Because you're getting half of what it was.
You're getting half of what it was, but you have to remember the negative too, because the negative will give you that positive 1. Yeah. I had one person today do that one mentally, but they forgot the negative. All right. Last slide that I'm going to teach you, and then we're going to do some practice. Okay, so that first one says blank over 4 is 9. What would the blank be? No. No. Blank over 4 equals 9. 36. Right? 36 over 4 equals 9. Does that make sense?
Yes.
Okay, so this is division. What's the opposite of division? Multiplication. Okay, so I'm going to rewrite this one because these are a little funky. All right, so I'm going to draw my line. And I know the opposite is to multiply by 4. Now, what did I teach you in the warm-up? If I'm going to multiply those two together, what do I get? Heard someone say it? 1, right? Because wouldn't this be over 1? What can you do with those 4s? Does this make sense? So what's left over here? Just 1y. Does that make sense? And what's over here? 9 times 4 is 36. And isn't that what you just told me the answer should be?
Yes.
Yes. Okay. So that'll work every single time. Okay, now it gets a little trickier. Can you do the next one mentally? Probably most of you cannot. Some of you might know how to do that mentally. So this is 1/3 times blank is 10. Okay. Now this you would do the same thing. That's 1/3 times x. So the opposite of multiplication is division. Okay. But okay. Now think mentally. When we divided fractions, how do you divide fractions? You multiply them. You multiply them by what? The reciprocal. You remember that? We do keep, change, flip. Okay. So instead of having to do a bunch of extra work and go keep, change, flip every time, couldn't I just go right to multiply by the reciprocal? Because that's what I'm going to do. So watch how this one works. Okay, when you have a fraction, you can multiply by its reciprocal. So the reciprocal of 1/3 is 3 over 1. Or just 3. So what does this become? 3 over 3 over 3. 3 over 3 is 1. Does that make sense? Do you see how it cancels? Or can't you do your cross canceling? What do you get? 1. The whole thing turns to 1. But if I do it to this side, I have to do it over here, right? So x equals how much? 30. Because 1/3 of 30 is 10. So that's the answer. All right, let's try that one again because this is the one that confuses most people. All right, 3/4 x equals 9. All right, what did I tell you to do? Multiply by the reciprocal. What's the reciprocal of 3/4? 4 over 3. Okay, so times 4/3. What happens to all of this over here? Cancels out and becomes one whole. Okay, here's my line. So I get x, but then I have to multiply the other side by 4/3. So hey, guess what? This is what we did in the warm-up. Right? I had you multiply. What can you do here? Cross cancel the 9 and 3. So 3 goes into 3 once, 3 goes into 9. 3 times 4 is 12. And this is 1 times 1 is 1. So x equals 12. Would you have been able to do that one mentally? Probably not very easily. A few of you might have been able to. Okay? All right, we're going to go in and do some practice.